22, home stretch, 2 more left. So at noon we have a ship A, and it's 100 kilometers west of ship B, and it's sailing south at 35 kilometers per hour. Ship B is sailing north at 25 kilometers per hour. And it's asking how fast is the distance between the ships changing at 4 p.m. Okay, so this problem is a classic. So we start originally with A being 100 kilometers west of B. Ship A is sailing south, so it's down here. Also, ship B is sailing north at 25 kilometers per hour. So you might be wondering, well, I'll write these down. 35 kilometers per hour, 25 kilometers per hour. And I want to know how fast is the distance between the ships changing at 4 p.m. I don't know if I flashed this up yet, but in case you wanted to read it, there it is. So the first thing I'm going to do is notice that this is a triangle in disguise. So I'm going to call this is a triangle. This bottom side is 100 because if one's moving north and one's moving south, then that east to west distance isn't going to change. And I'm going to call this distance between them y. So then d is going to be the distance. So if we think about it for a second, y should be equal to 60 times t, right? Because if one's sailing down at 35 kilometers per hour, the other one's sailing up at 25 kilometers per hour, then I should just add those together. Because the distance, the vertical distance between them is going to be increasing that much. So I need to see how are all these related. Well, actually, first I need to say dy dt is equal to 60. That's what I just explained. They're moving apart to the tune of 60 kilometers per hour. Here it feels weird to write dx dt, but that's kind of that x distance is 0 because the distance between them is always 100. I might need that, I might not, but I'm just going to write it down. How are all these things related? So this is where I find out I didn't need to write that. Y squared plus 100 squared is d squared. So take a derivative. This is kind of the problem you run into when you use d, is now I'm taking dd dt, which there's nothing inherently wrong with that, but it doesn't roll off the tongue very well. So 2y y prime plus this should be 100 squared. 100 squared is a constant, so you get 0. Here you get 2d d prime. So I'm going to cancel the 2's. I have a 2 on both sides. Or I should write it y dy dt equals d dd dt. So now I have to go back and see what's y and what's d. So at 4 p.m., 4 hours have passed. So y is equal to 60 times 4 is 240. At that time, d is going to be the square root of y squared plus 100 squared equals square root of 240 squared plus 100 squared. So by calculator, I get exactly 260 equals 260. Okay, so d is 260, y is 240, we plug in. 240 dy dt is 60 equals the distance 260 d dt. So then d dt, the thing I'm looking for, is 240 times 60 over 260, which is roughly equal to, if I plug in, times 60 divided by 260, 55 point, rounding to 2 decimal places, 0.38. And my units are, what, feet per second? Kilometers per hour.